entropy. So we know that steam is gas, H2O gas is steam. So does steam contain entropy? Yes. And why does steam contain entropy? Because entropy is what type of quantity? Yeah, so entropy is a thermodynamic quantity, and we know that substances contain these thermodynamic quantities such as entropy, or internal energy, or enthalpy. Okay, so again, steam does contain entropy. Does steam contain work? No. Does steam contain heat? No. Is steam hot? Yes. Is steam cold? No. Well, it's relatively speaking. It could be hot or cold, depending on whatever relative temperature you're referring to. Okay. Now, these driving forces, enthalpy and entropy, tell us whether a reaction occurs or does not occur. So we can relate entropy and enthalpy by this new quantity, free energy. So if we look at the change in free energy, that's related to the change in enthalpy and the change in entropy by this formula. So delta G is equal to delta H minus T delta S. Delta G tells us whether a reaction occurs spontaneously or not. So if delta G is greater than 0, that reaction is not spontaneous. If delta G is less than 0, that means that reaction is spontaneous. Now, before we go on, what does it mean that a reaction is spontaneous? So I'll give you two examples. Burning wood is a spontaneous reaction, whereas photosynthesis is not a spontaneous reaction. So what's the difference between those two reactions? Okay, so when you burn wood, did anyone go camping over spring break? No. So no one had a campfire over spring break? Ryan, didn't you tell me you said a big bonfire or something?
Oh, yeah.
Were you burning wood? Or just throwing books and things? Books and notebooks and things like that?
Mainly books and stuff.
Yeah, so when you burn wood, so here's your piece of wood. You have a piece of wood at room temperature and pressure. Does it burn? How do you get wood to burn? Yeah, so we've got to heat up the wood. We heat up the wood by lighting it on fire. Once it's lit on fire, does it continue to burn? So why do you have to heat up the wood?
To get over the activation.
Yeah, to get over the activation. So really what we're doing here is we again plot energy versus the progress of reaction. Okay, so this is the energy of the wood. Nope, we got to overcome this activation energy barrier. This is why we have to heat it up. And did I draw the energy of the products correctly? Should it be lower? Should the energy of the products be lower in energy than the wood or higher?
Lower.
And how do we know that it should be lower? Yeah, this is an exothermic reaction. So once this reaction starts, it'll continue to occur without any help from additional heat. Okay, so that's a spontaneous reaction. Okay, so once the reaction starts, it continues to go. And it'll continue to go until all the wood is burned up. Okay, so when there's no more reactants left over, that's when the reaction stops. Now let's take a look at photosynthesis. Why is photosynthesis not a spontaneous reaction? So if you look at the photosynthesis reaction, what happens in photosynthesis? Yeah, we need sunlight. But what are the reactants in photosynthesis? Yeah, so you need CO2 and H2O. And what are the products? C6H12O6. And is there another product? Yes, O2. So when you have CO2 and water present, will that spontaneously form C6H12O6, glucose, and oxygen?
No. Sunlight.
Yes, what's the sunlight? Yeah, we need sunlight to do this. So will photosynthesis occur without sunlight? Yes, so note that for this reaction, energy needs to be supplied for this reaction to occur. If the energy which was supplied is removed, then this reaction won't occur. Now note that if we look at the reverse of this reaction, is the reverse reaction spontaneous? Yeah, so when you have C6H12O6 or glucose, when that reacts with oxygen, that forms CO2 and water, is that reaction spontaneous? Yeah, it is. Okay, so if you look at a reaction in one direction and it's not spontaneous, the reaction in the reverse direction is spontaneous. Okay? So in other words, if you look at a reaction in one direction and it's spontaneous, the reverse reaction is non-spontaneous. In other words, you can't have a reaction which is spontaneous in the forward and the reverse direction. Okay? London.
Nuclear fusion is spontaneous? Like an atomic bomb?
Yeah, so we'll talk about that later on in the semester. Once you can make it spontaneous when you get to that critical mass. And once that critical mass is attained, then the nuclear reaction which starts will continue to occur. But you have to get that critical mass and nuclear chemistry. We'll talk about that. Okay. Is the dissolution of salt and water a spontaneous reaction? Okay, so here's some water. You put some salt in there, and when you put salt in water, what happens? Yeah, so the salt dissolves and forms sodium ions and chloride ions. So when you put salt in water, is that reaction spontaneous? Yeah, that is. And we can describe that reaction by this equation. NaCl solid goes to Na plus aqueous plus Cl minus aqueous. Is boiling water a spontaneous reaction? No. Why is it spontaneous? So if you have water in here, is it just going to boil all by itself? No. Yes, you have to supply energy to get that water to boil. And how can we describe the boiling of water in a chemical equation? Yeah, so we have H2O, liquid, going to H2O gas. Yeah, so we have to supply energy. So note that heat is considered a reactant. So this reaction, is it endothermic or exothermic? It's endothermic. Delta H is that reaction. Okay, let's continue on. How does each driving force, delta H and delta S, and temperature contribute to make a reaction spontaneous? So there's 4 cases. So in case 1, if delta H is greater than 0 and delta S is greater than 0, is delta G going to be greater than 0 or less than 0? Okay, so let's take a look at this formula. Delta G equals delta H minus T delta S. So if delta H is greater than 0 and delta S is greater than 0, will that make delta G be greater than 0 or less than 0?
When the temperature would be down there,
So what are you saying?
it would depend on the temperature.
Yeah, so note that for a reaction to be spontaneous, we want delta G to be less than 0. If delta H is greater than 0, that does not help delta G be less than 0. If delta S is greater than 0, note that we have a positive delta S, but we have a minus sign here. Okay, so that makes this term negative, but the temperature will determine whether delta G is going to be greater than 0 or less than 0. Okay, so in this box here, it's going to depend on temperature. Okay, so what I'd like you to do is to figure out the sign of delta G for case 2, 3, and 4. Okay, so once you have an answer, compare your answer to the person sitting next to you. See if you get the same answer. Okay, so for case 2, for case 2, when delta H is greater than 0, delta S is less than 0, what's going to be the sign of delta G? Yeah, it's going to be greater than 0, so note that, again, if delta H is greater than 0, that helps delta G be greater than 0. If delta S is less than 0,